Hello, just checking out how my sound is working. If it's working okay. No, I don't know. Check go that. Nice cat photo. All right, so I wanted to see if how many of you are before we get going. I want to find out what the heck's going on with this whole groups thing. It's driving me batty. I don't know what the it shouldn't be that hard to set up a group. It's really frustrating. And I don't know what you guys are seeing. So that's part of the problem with this. So I wanted to see if we can figure something out for that. Let me also, what's the best way of doing this? I'm just going to set up everything, set up shop, and then we can go start talking about what I'm seeing, what you're seeing. Maybe, I don't know. We'll find out. All right. Mhm. Okay, so it says you're a member of more than one group. Let me actually show you what the groups look like. Hopefully you'll be able to show that in a second. The best way of doing this. Yeah, and that seems to be a problem, but I'm looking at this going like, I shouldn't be, you should, everyone should always be a member of more than one group. It's stupid if we're not a member of more than one group. It makes no sense. Uh, okay, so here are the various groups in the course. You Everyone's accounted for. There's no other groups other than maybe it's groupings or groups. I don't know what the heck a grouping versus a group is. Right? I thought there was even a default that everyone's automatically part of. But if you're part of the default, uh, everyone else is people that are not in any particular group because they're not actually really participating in the class, and the TAs and myself. Everyone else is in a group. You're not listed across multiple groups. I checked with you, Isaac, for example, just to make sure. Uh, I don't even know what the overview is, but this is just so here is the entire class roster right here, 33 people. So is that a group? I don't think it's a group, but you're all part of multiple groups as a result. So yeah, I'm not going to remove you from that particular group, and therefore I don't know what the heck's going on. So I don't see what you're seeing. By groupings, no groupings, doesn't matter. Group, see, no group. Uh, Anyone in the no group? Nope, there's no one in the no group. But this is a group, so this automatically is the class. So I don't know how I'm supposed to get rid of everybody without like severely destroying everything that we have. And that's where I think part of the problem is. I don't know what you're seeing. So maybe I'm supposed to use a grouping or something like that. My plan right now is if it's not an easy solution, if people, I mean, I wouldn't mind one of you guys looking at it now to see how you submit what you actually see, and maybe a screenshot and throw that up there in the chat or something like that. Simply because if I have a photo, I don't see what you see, and so I don't see what is necessarily wrong. Hold on. Flaring overhead ceiling light. I don't necessarily see what you see, and therefore I don't know exactly what's going wrong somewhere along the lines. If I go back to over here and I go to 3, edit, settings, I, there is almost nothing in here that Group submission settings. Submit in groups, yes. Require group submission, yes. Grouping. Oh, I could do groupings. I can see about that. But I'm almost at the point right now that I'm just going to say, screw it. We'll do individuals and one person per group, like we did for P2 and P1. One person per group submits something and just done with it. Because I know this is causing you guys stress, but it was not meant to cause you stress. It was meant to streamline things. And if, oh, on a Tuesday, you're not allowed to do this, if it's like, yeah, this is what I'm seeing. It could be any group. As long as you're in a group, you can submit, and you need to be in a group to make a submission. I have the groups. You're in a group. I don't know why it says, um, why this issue is, what this is. But I still also get, you're in multiple groups. So if I go to P3 initial sketches, I get this require group to be a submission is enabled. Some users are not a member of any group, but you guys all are, or are a member of more than one group. But the main one should not be considered a group. So I don't understand what the heck. You don't have a submit button on the page. Okay, but do you see everything else? Didn't you?
I can only see the page says I'm a member of another group, and there already has been a submission, so I can't submit anything else from the page, and there's no submission bar or button there.
Oh, right. Nice. Isaac just sent me an image here. Same with me. Okay. Yeah. Well, I mean, if everyone's in the same boat, we're all in the same. You're all in the same boat. So I want to fix it for everybody. But um, it's not going to pop up. It's going to pop up on for everybody to see. Yay! I want to move this over so I haven't looked at the image yet. I don't know if this confidential information. Oh, son of a. Okay, this is one. Remember more than one group. Let me try the grouping thing, and then if I can't, immediately after class, and if I can't get that, it's going to be one person per group submits something, and it's going to be individual assignments again. That's or we could just do the individual assignment thing right now and just be done with it. And then for assignment 4, we try one more time, because I'm really, you guys should not be feeling stressed about this. It should not be causing anyone any kind of stress, but I understand why it's stressful for sure. Yeah, let's do that group. No, okay. Restrict access. Move that restriction. Hopefully that'll do it. I hate everything, everything in the world, just the whole thing, everything. Um, mission settings. Sorry about taking up valuable time here, but I'm just going to want to. Why isn't it letting me submit? Oh, changes. Yes, this is one of the reasons why we're trying to move away from CU Learn, because CU Learn has some great qualities, and then it has something like this. So it's just, what? Why would you put it somewhere where I can't find it afterwards? Manually reopening, unlimited attempts, set statement, and nothing for how you get rid of students and groups. I think it might be yet another page. No groups. I think that does it. Nope. I will figure this out. I will just punt. Uh, I will just punt, get rid of the groupings, and be done with it. It's driving me nuts. Um, I'm so annoyed with you learn right now. All right, so I'm gonna punt. Make sure I punt. If you don't see this removed as soon as possible, remind me, and I'll make sure we get rid of all the groups, at least for now. I'll figure out if groupings will work for P4, but I mean, it should not be rocket science. Okay, so that's my view on this whole kerfuffle. Yes, I said the word kerfuffle. Um, So I want to look at cognition. This is our last part of. So you thought you were in a an IT degree and yet you're doing psychology because well first of all I paid good money for my psych degree so I figured I probably should explain that. That's not the reason. Uh, the real reason is because it directly relates to what we're trying to do here. That this cognition, this perception stuff, it's directly related to it tells you how to design things because the reason why pie charts don't work as well as people think that they do is because of the psychology, because of the perceptual principles. The reason why we have, we design things a particular way is because of how our brain works. And so we're doing one last dive into this thing, see how far we can get with it. And then we're going to cycle back into the visualization stuff. We just needed just enough visualization stuff at the beginning of the course so you can do P3 essentially. And the really nitty gritty details, they can come later. So if your P3 doesn't incorporate every last little nuance or quirk for, in Viz research and the Viz literature, I'm okay with that. But it's just a matter of having a nice initial guess, an initial pass at this. Ideally, we'd teach the entire course and then say, hey, design stuff. But, that's not possible. So we're going to do a little bit more perception. Hopefully, we can get to some fun things. I'm going to blow through Gestalt principles simply because I think, correct me if I'm wrong, and please correct me if I'm wrong, but I'm assuming you've done something with Gestalt principles in previous classes. They're too easy and too pretty looking for people not to avoid them normally. Yep, there you go. So we're going to breeze on through Gestalt principles. They pop up everywhere. The interesting thing about them is they were completely not improvised. They were not empirically validated for like 50 years or more, right? There are people going, yeah, I think that's a principle, and just that was it. So very lucky that they actually worked as well as they do, but yeah, they were not founded or based in the psych literature and a number of other things. So which is why I don't necessarily trust all aspects of it. So we're going to learn about contours and textures. We're going to look at some Gestalt principles as they relate to visual perception. We're going to look at visual attention and learning and understanding. So here's the kind of thing that we have. Why is it that we see things like this if we have a whole bunch of other distractions, or if we have these distractions here? Why is it that we see these series of orange circles being their own line, this black line being a line, that we don't actually mix the two up, that all these distraction ovals in the background we actually see the lines on top of it, right? There's a whole bunch of visual clutter in there, yet we see the main contour there. All these distractions sort of go away. And the reason for that is actually how we perceive things. So what we're looking for is contours. In fact, we actually have um, perceptual processing or visual processing hardware, for lack of a better term, that's keyed in for this. That's how we see things. We are looking for contours, even if there shouldn't be even if we shouldn't be seeing contours. That's how we see the world. So we don't see a whole bunch of little images. We process the individual parts of it. It's actually the part of machine learning that they have more difficulty with. What is signal? What is noise? And it turns out this is what the first 2 years of your life approximately is getting this hardware up and running. That's the reason why you give babies shapes to play with. That's the reason why babies like primary colors and like looking at particular things. They are learning how to perceive the world and how they find these contours. You're predisposed to acquiring that information, but if you don't give somebody enough stimulus in like visual stimulus in the first 2 years of life, they actually cannot see the world correctly. They unfortunately, for ethical reasons, I guess, learned that when they would do experiments on cats when they were kittens and limiting what they were able to see in the world, and as a result, what they could see afterwards when they fully developed. Psychology is not a nice field always, but this is actually what we're seeing. So we can see a bunch of different textures. So you can differentiate based on the grain size, the size of the pattern of the texture, the orientation of it. So notice that you'll see two different, we have an outside ring and an inside ring. And only real difference is it's been rotated. The texture itself is about the same. The granularity or the grain size of this thing, or the contrast at least in here, though this is contrast. So, didn't really matter anyways. I will say grain size, orientation, contrast, you actually will automatically see where that edge is because everything that we do is based around the difference from the nearby environment. So blue is only blue when next to another color. And the reason we see these different contrasts is because small little differences, you get a grain to it, but we're looking for larger patterns. So these are the things that we're really good at processing. So difference in orientation, really easy for us to distinguish where that line is. Boom, right here. The size of things, the amount of contrast of what the image looks like, or the actual shape. Really good at figuring out these textures. And you'll got a pop out effect like we've seen with color. So if you're saying find the largest value, really good at that. Or differentiate small from large items. Or if you orient things a certain way, you can distinguish one item from another. So if I have a scatter plot and with different shapes, I can distinguish them really easily. Versus, so where's the line for this? The orientation is actually different between these things, but it's orientation in an oddly shaped figure that has to be rotated only a slight degree. Or what is this actually doing? This is it's simultaneously changing the shape and the color. So I go from red squares and green circles to green squares, red circles. The line is approximately right here in the center, but we do not see that clean line. If you simultaneously change multiple elements at the same time in opposite ways, you don't get this pop out effect. You don't get this clean line where you distinguish one side from the other. Or if the shape have a lot of things in common, like it's not curved versus sharp corners, but multiple sharp corners. So I have a sharp corner here. I have what's a T shape, but it's a sharp corner essentially, and your brain doesn't distinguish it. So what we're looking for is things that will automatically give us this differentiation between the two. And you can have interference, and that's what we were seeing in the previous case, where if I change multiple aspects at the same time, it interferes. Same with text on a background containing similar features. Will be very difficult to read even though the background color is different, right? The background and foreground color, I should be able to easily distinguish them, but I'm looking for these edges. I'm looking for, perceptually, looking for where curves and edges aligns, and I'm trying to find continuous patterns in my visual field. So the low contrast backgrounds, easy to read. This is really easy to read. No one has problems with this. It's a bit harder, and this is really hard. And all that is that all the only difference in the two is the features are very similar and they're very bold in both cases. I thought I had something about visual processing. Okay. Um, so I didn't have the full part of it. I wanted to go a bit more on this. What I'm looking at in my visual field is, remember, I have cases where I'm seeing simultaneous, if I see edges based off of one neuron fires, nearby neurons inhibit that. Well, I also have patterns further down in my, my visual processing, where I have activation, 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 and I automatically try and find a shape in a series of activations. So activations near each other cause me to automatically highlight. I perceive it as a curve that's all connected together. I automatically do this right back here. And little short things, little short amounts of a contour, I don't. So what my brain is automatically trying to find these simultaneous contrasts or simultaneous um, or sequences of darkness or sequences of lightness, and I'm trying to find these contours. That's actually what my visual processing system is doing. And so this is why we have our Gestalt principles, because that is just the manifestation of that. I'm looking for things that are similar, and I can group them. So Gestalt principle of similarity is I will group things based off of similarity. This is just how these are rough heuristics for how I perceive the world. They were not originally founded in the psych literature. It just happens to be a nice little shorthand for what we're talking about. So similar objects are deemed to be similar. They're related to each other, whether I want to or not. Similarly, proximity. Things that are put together are related, whether you want to see it or not. Now, some of these also might be cultural. So a lot of this you'll be, they're like visual metaphors, if you will, that you've learned over time. Some of them are innate to how you process the world. It's very hard to split that hair to distinguish those two. But proximity, for example, I think would be presumably universal across different cultures. It's not a cultural thing. It's more like that's how we see the world. How things are aligned. Things that are aligned together are grouped together. So if I have these two are together, these four are together, these four are together, despite the fact that the shapes are not the same, the alignment, you also have proximity as well. The alignment, but these as a group are related together, let's say. If I connect it with a line, this is where it starts getting metaphorical. If I connect it with a line, I automatically assume they are grouped together. These three are together. Despite the fact that there's a big separation, I perceive these three as a group, these three as a group, maybe this as a higher level group of that. If I put a line around it, these are all in one group. Why? Because they're enclosed. Really strong metaphor. If it's in the box, then it's in the group. Common feat's always one of those weird things. And if things move together, they are together. So whether I have boxes around or anything like that, if they're moving together, I automatically will group that as a common object. It makes sense, right? If you're seeing things, the bunch of curves moving towards you is probably the tiger about to eat you or whatever the case is, right? That's what you're designed to see. So Gestalt just means form in German. And these are just, they're not just the basic bunch of stimuli. They are, they transcend the visual stimuli. They're things we automatically see from our visual stimuli. So if I connect something with a contour, these two things are connected, irrespective of how that contour is shaped. I can connect two things. If I just put a line between them, I can enclose things and I automatically group them. If I color them different way, those groups differently, they are different groups. If I change the texture, they are different textures. If I color things a particular way, if things are grouped together based on proximity, they are related to one another, or they have some similarity to each other. If they're aligned together, I automatically will read certain things. So we looked at similarity, we looked at proximity, looked at alignment. For me, I think a lot of people will see this, but I'm not sure if everyone sees this the exact same way. That's how I view these. The alignments are horizontal rows this way, vertical columns this way, but they're all aligned, so you could read it one way or the other. But if things are aligned, you automatically want to group them together. And then I can group things based on similarity, connectedness, or closure. Fine. Here's why we do this. Here's a scatter plot. Now, you can group by similarity, but this is actually relatively hard to do. So the black squares versus the black circles, I can sort of visually separate them, but they don't really pop that much. So I have similarity. That's just one Gestalt principle. If I apply a second one, I also do similarity based on color. It makes it even stronger. Or here's if I put connections between them, now suddenly I will automatically see all of this. Why line graphs work better than scatter plots for finding the contour, because I automatically will group all of these together. Even with all this interference going on, this is a lot easier to find all the yellow, all of the circles rather than all of the squares. I'll even do things that are complicated like this right here. This is actually the problem with with lines though, that if I have a line of best fit, I will see it whether I want to or not, whether it makes sense or not. So I can get a full scatter plot. There's no correlation between anything. I put a line across it and people go, there's a correlation, whether you want to or not, because you automatically see it. So this is how you lie. Effectively, we should have a course like how do you lie through visualizations, because that's I, learning what to do also teaches you what not to do. So what not to do would be, I don't have anything there at all, and I'm going to pretend I have something there by putting the line, connecting them together. And notice I have a common fate here. This is one of the Gestalt principles, right? By having the square here, having the square here, having a line, and then breaking the line, I enclose it anyways. I will continue to see the line anyways, even if I don't want to. Here's another example of it. But notice, and what's special about these points? Oh, they're grouped together in this circle. And therefore, these 4 points are somehow related to each other. Don't know why, don't know how, but I automatically see these 4 points as something special that I'm calling attention to. They're related in some way because they're enclosed in this red dashed circle, which, oh, by the way, enclosure, another Gestalt principle. Similar, but this has similarity, the squares, the shapes, connectedness, the lines, and enclosure to tell me which group I'm in. It also has common. It doesn't have common fate. It has, I guess, it's closure as well for this right here. I always, yeah, there's closure. The fact of the matter is, there is no triangle here, and yet everyone sees a triangle here. Or I'm assuming everyone sees a triangle here, right? This could be a bunch of Pac-Mans all pointing towards each other. But the fact of the matter is, I want to fill in gaps. I want to see the world, even if there's nothing there. And so by just putting these lines here, there should be actually 3 line segments and 3 Pac-Mans. And instead you see lines that are connecting behind an invisible white triangle that are always overlapping on top of circles. Similarly, there is no square. There's no circle there, but you see a square and a circle. And you can do entire logos and entire things on it just using that closure. So closure allows you to see an image of a panda bear, even though there's no actual panda bear, or a cube on top of a bunch of circles. That's what the principle, and that's how we're seeing the line in the background. You want to fill in the gaps. You want to see symmetry here. You want to see 2 faces or potentially a mug, chalice. More importantly, this is an example of multi-stability. The case we were looking at rabbit and rabbit. This is the term I was looking for last time when we were talking about rabbit versus duck. When the image of a rabbit duck, and you can see one or the other, the old lady and the damsel, I think is the other one of the other ones. You can see one or the 2 images at the same time. I don't get multi-stability for the black and blue dress the black and blue dress versus the gold and white dress. I cannot see the gold and white dress. But multi-stability allows me to simultaneously switch between seeing the cup, seeing the faces, seeing the cup, seeing the faces, just switch back and forth. but I like seeing things that are symmetrical, and I will see things in the image to make it symmetrical. Like there's a face here. Things that are aligned I see together, right? So all these are aligned in a sequence, and so therefore I will see these circles. Despite the fact that there's this disruption of a gray square in between, I want to see this edge here, not flipping around this way. I want to keep going with the edge. So we looked at similarity, we looked at proximity, we looked at connectivity. I just want to grab bag a list of things for you to look at if you want to refer to them later on. Although Gestalt principles do not count for as much for justification of your designs as other principles that we'll get to later. Continuity, we'll see complete hidden objects, simple familiar shapes. So yeah, that's continuity. The closure, well, we call it closure, but it's continuity. Closure is we see incomplete shapes as complete. We complete hidden objects. Okay, so the line is continuity. The line on the line graph is not closure, it's continuity. Ah, Germans. Okay, so the figure and foreground. Elements are perceived as either figures or the background, not both. You can switch them back and forth, but you don't, they're not both the foreground and the background. That's what we want to see. Common fate, things that move together in one direction are perceived as a unit, like a swarm of flies or a flock of birds, right? That it makes sense from an evolutionary standpoint. But here's where it gets fun, or maybe not fun, but I think it's fun. There's also other ones like good Gestalt and a couple other Gestalt principles as well. Feel free to use anything that you find. But if we have nesting, we actually, these principles come into play for how we convey relationships. So if I have hierarchy, I can nest things. So things that are inside of another object are either a sub object or they are part of the main object. So we have nesting. We have if concepts overlap. We physically overlap the visual representations. It may be metaphorical, it may be perceptual. I'm not sure, but it works for everybody that you're going to show. So if I have, that's why Venn diagrams work essentially. And if I want to connect things, put a line between them. They get connected. Now, if you have too many lines, you don't see it anymore. So you have to be careful about this, but that's why that's why node link diagrams work. And if I want multiple differing relationships, I can represent things different ways, like using color for one, shape for another. So, and then maybe multiple lines connecting it, showing some other information. I can encode a lot of different types of information in each one of these visualizations. If I have like a tree hierarchy, I will automatically see this branch over here as separate from this one. Why? Proximity, also connectivity, and also similarity. I got three Gestalt principles telling me that these are grouped together as in a relationship, but since they are under this main point, they are nested. They are part of this hierarchical information. So in terms of overlapping concepts, Venn diagrams are the classics, right? By the way, Venn diagram, I found this out as a grad student, I think. There's an Euler diagram and versus a Venn diagram. Venn diagrams show all the different ways sets can be combined. An Euler diagram just show the sets as that exist in a data set. But that's not going to, I'm not going to be testing on that. But the idea, like, if you're in A, B, and C, you have all three of these circles overlapping you. That's the metaphor that we're dealing with. And it's very effective for, highlighting things, an overlapping concept. The things that are all highlighted in a group, they are grouped together, or I'm highlighting all of them. If I have an overlapping concept, I can overlay something. This is what's called a tree map. It is considered one of the, for many, the brand, we invented some brand new way of visualizing information. Oh, look how awesome it is. I don't particularly like it myself. I'm abnormal in that respect, but Ben Schneiderman came up with it. He's a very big name. He also does great work. If you tell me you type on your phone when the and you type a letter and the letter gets bigger. That's Ben Schneiderman's work as well. But he came up with this idea of a tree map. The idea is that you have a rectangular area, you subdivide that rectangular area into what other items are in your rectangle. So if effectively a tree, so top level of the tree is here, branch here, branch here. Parts of your tree, parts of your hierarchy are within the main tree. And then you subdivide, subdivide, subdivide. So the space used to fill in each one of these squares inside of, so inside of this are one part and the other part of the tree. So I subdivide my main squares into by the children of it. You can do like a file, like your file system with this. So here's your C drive is the entire thing. Here is your downloads is another one of your subfolders. Here's another folder. Here's another subfolder. And if you're just coloring them and you're subdividing these squares, you can represent a hierarchy. It's space filling, as in there's no wasted space. There's no, because trees get really, really broad and really, really big and really take up a lot of space. This thing is very efficient in terms of space. It's also really hard to read, and you need to sort of practice reading these things. But this would be an example of a nested concept. And here's connectivity. So I select this purple circle, and everything involving Peugeot cars gets selected in the text, and maybe a picture of a Peugeot shows up here, and or maybe I'm selecting this car down here, and their corresponding cars of that make are showing up here, and then showing up here. This is when we talk about brushing and linking, this is what we get. Connectivity is one of the ways we can do it, but just showing a line, connecting, physically connecting two concepts. It is amazingly efficient if it's transitory. What I don't want is all the lines showing up all the time. That's where when we get to interaction, that's what we'll see. The act of you selecting something and then the connections, the lines showing up, that's effective for connecting what seemingly disparate concepts. But I can't show all the lines all the time. I love this particular example because it's weird that we can all read this, or most of us can read this. So feature level tuning can allow us to attend to different layers of information. Can someone read out or write out the yellow letters in the background? And while someone's doing that, can someone tell me what the like black or gray, depending on your perspective, things in the background of that are? Yep, nice. Everyone's very fast with the pie. And that's pie. What are the black shapes in the background? Or what are the black things in the background, I should say? Yeah, they're shapes. That's coming. Yeah, we have a triangle, we have a plus, we have a, I don't know if you know what that one is. It looks like a circle, but it's not quite. Circle, X, plus, heart, square. I don't know what that thing here is. But they're shapes. The fact that you have all of this interference all the way down, and yet you can read off the yellow letters, you can read off the blue text, you can read off the shapes in the background. That's wild. Sorry, maybe I'm too impressed by our visual processing system, but that's a lot of noise on the way to get there. It is a circle. It just looks like a weirdly shaped circle because of the bottom here. But yeah, the fact that you can actually see that is freaky in my books, right? That's awesome. So we can actually attune to different layers. As long as they're significantly different, I can put layer upon layer upon layer, and I can tune out certain things. My visual processing system is geared towards this. That if I can see a whole lot of green stuff, but then I can tune it out and look for a particular shape in a sea of green objects. Or I can look for a particular color in a sea of similar shapes. I can tune out or attune to certain things. It requires attention. That's what we get to very, very soon. That's where the cognitive part comes in. Because if I don't tell you people what to attune to, it may not pop out. Or it may not be obvious what this is. Until I told you to look at what the shapes in the background here are, you may not have seen that there are a bunch of different shapes. And we have particular graphical semantics. Maybe I'm like avoid some of this, but essentially, if I can order by based on these Gestalt principles, so I can use contour, texture, solid shapes. For example, here, how many different ways could I group this thing? Well, let me think here. I have monochromatic 1, 2, 3 versus using hue. I have convex shapes, concave polygons, 1, 2, 3. These 3 things here. This happens to be the same 3. Oh no, 4 things here versus these 2. No, that's also convex as well, but there's a slight. These are the same shape, I guess, in all 3 cases. If I said concave shapes, everything but the square would be included in that group. If I said green versus not green, if I said has sharp angles, there's 2 things that would be included in this. Right? I can group it a variety of different ways. I can also order it spatially, irrespective of the shape. I can based on proximity. I can have I can change the shape, color, texture, but then I get sort of interaction effects, and I can have different sizes. And sizes and position and height automatically convey magnitude. This automatically conveys entity. It's categorical in nature. This is automatically ordinal in nature. If I spatially order it, this is the smallest, this is the largest. If I group by proximity, I get closure. If I put some closure in there, I get relatedness. This is related to this based on proximity. Or I can use categorical information or shape and texture to also convey relatedness. If I want to show connectivity, I can just put a line between. So connected by a contour shows relatedness. There's a path between them, 2 of them. The thickness of the path shows the strength of the relationship automatically. The shape of the path tells me the type of relationship automatically. If I enclose things, depending on how I enclose it, it's containment and also can convey how it's contained or how it's related. What, like this is filled, this is not filled, it can convey other information. I can convey multiple different things. I can do, if it's a blue circle, now it's a filled blue circle versus not filled. Filled blue circle with a texture might convey something else. You can't overdo it, but there are a whole bunch of different options for you to play with at any given time. If I nest things, I automatically get a hierarchy. So this is inside of this, which is inside of this. So this is a grandchild of this set here. And if I attach things, just plop them right next to each other, I get structure. It's parts of a concept or conceptual structure. So that's Gestalt. Very fast Gestalt there. There you go. I love this part just because I like pointing out how wonderful / terrible humans are with certain things. So here we go. I have a stimulus. I have short-term sensory store. That is visual information goes down to the back end here, and I visually perceive it. Very, very, very limited amount of time for that. This visual perception, this short-term visual perception, visual sensory store. Your perception is based off of that and other things. So low-level feature analysis, I have less than 200, it lasts for less than 200 milliseconds from when I'm looking to the next thing that I'm keeping in my head. 200 milliseconds. Very, very short period of time. So like a little flash, I'll see it, but I won't stay in my head for very long. Your working memory is less than 30 seconds, and you can. This is the grand charlatan comment of all time. So let me go on and put down my soapbox for a second here. If you see people talk about 7 plus or minus 2, run. Not run, but this idea of 7 plus or minus 2, the original authors of the paper don't agree with it, their conclusions anymore. It got so overgeneralized, so overused, and so misinterpreted that the original authors of the paper said, no, don't even bother with this thing. It was a very nice, clean result. The idea is that how many items can you keep in your head at any given time? 7 plus or minus 2. And then the logic is, Well, that must be why our telephone numbers are the way they are. It's not the reason at all, by the way. It's just accidental coincidence and convergence. Um, but 7 plus or minus 2 is supposedly the number of items that the average person can keep, numbers, like random numbers or things that a person can keep in their head at any given time. Doesn't really work that way, but it's a nice rough estimate. So you cannot assume people can keep, if you give me 20 different numbers, I will not remember 20 different numbers. Like 20 random pieces of information at a time, I won't keep those in my head, which is why we have visualizations. Because your job is not to have people remember these numbers. Your job is to let them find those numbers quickly and easily, so they can back up whatever point they want to make. So your job is to externalize that. They don't have to keep it in their head. It's on the screen. But your working memory is about 30 seconds, and it doesn't hold much. Long-term memory, much, much better. So long-term memory, it's greater than 30 seconds. It's painfully unreliable. We have in our heads an associative memory, as in, much like machine learning algorithms do the same thing, actually. As in, each neuron is connected to a whole bunch of neurons, which connect to a whole bunch of neurons. You need a certain number of neurons firing to make the next neuron fire. So there's like thresholds. And all your neurons are all adapting and changing constantly to hook up to other neurons. They're constantly growing and reshaping and reforming. And you might imagine, if you have a system that is based off of correlation and association, and on top of that, you have it that it's constantly changing, what you think is reality is actually your brain constantly changing and lying to you. So you will fill in the gaps, much like you fill in the gaps for your eye when you don't see your blind spot. You fill in all the gaps for all of your memories that you don't remember. It's dangerous to ever proclaim that you remember and you are 100% guaranteed to be right because of that reason, including me doing this lecture. For all I know, it could be wrong all of the time. I hope I'm not, but these things happen, right? You'll fill in the gaps. So there's famous studies, I think that's from the 50s or 60s. They asked people to remember Pearl Harbor. What were you doing during when Pearl Harbor was attacked? And people would be saying things like, "Oh, I remember it was a World Series was happening. It was a bright sunny day, and then I got the news on the radio that Pearl Harbor was attacked by the Japanese, and this big long story." Except maybe you guys don't know this. Uh, when I would teach Americans this, they even wouldn't know this. Does anyone remember when Pearl Harbor was attacked? I'm not holding my breath on this one. Not the exact date, but approximately. Someone's Wikipediaing it. You'd take too long. It was December. There's no way in hell the World Series of baseball was going on in the middle of December. So they're filling in gaps. They remembered the World Series. They remembered Pearl Harbor. They somehow correlated the two together. Good enough. And that's what their new memory is. It's not factual. It's faulty. So we have this faulty long-term memory with this incredibly short-term memory. It's surprising we're not still living in caves to a certain extent. But there's one other wonderful little wrinkle in this whole plan. We're going to get to it in a second, but once I have perception, decision and response selection is I perceive something, what I pay attention to, and how I respond to things changes my working memory, which changes my perception, which changes what I'm looking at, which changes my working memory, which changes it like all the way around. So when I say, here's a picture of a duck, now look at this rabbit and duck picture, you will see a duck. There's perceptual priming to that. And then on top of that, that tells you ultimately what your long-term memory gets in the end. So I'm hopefully, there's a couple of other little bits. For one of them is we have different channels for verbal and visual information. So when I tell you something and I show you something, they are different. You'll remember this slide differently than if I showed you an image of things. Verbal working memory is different from visual working memory. So we have essentially two different working memories. And for visual working memory, it's controlled by attention. Verbal, presumably, as well as differently. Our attention changes every 100 milliseconds. And this approximately this is a gist. This is the 100 millisecond snippet of time that we can perceive something. And we get some weird artifacts from this. And without any choice of your own, the information getting fed from from working memory to long-term memory, not up to you. What you remember, ultimately, there's some tricks you can do to try and reinforce long-term memory, but you really don't have direct control over it. That's actually where your hippocampus comes into play. Two little horse-shaped things on the sides of your head in the temporal lobe that cycle and loop around, reinforcing some information that you got during the day. It's also the injury that the guy has in Memento. If anyone watched that movie, great movie. Okay, power of visualization is that we can have a far more complex concept structure represented externally in a visual display that could be had visual and verbal working memory. That's essentially what we're doing. When I give you a whole bunch of, so I'm playing D&D with my sons. My oldest is, I don't know how he's so much smarter than me in so many ways. So we're playing D&D. I'm fighting a fire giant, if anybody knows what the fire, 162 hit points on this thing. And we're getting random numbers rolling, random attacks, all these numbers floating around everywhere. And then I'm writing down how many hit points trying to track, I shouldn't be doing this, but I'm doing it anyways. Trying to track how many hit points this fire giant had, how beat up this fire giant is. He's keeping all of these numbers in his head. He's somehow doing all the calculations in his head, not writing anything down. Mere mortals like myself have to write things down. Why? Because we're not good enough at this. It's not a fault as us humans. Our working memory is only so limited. And so the best thing to do is externalize it. Put it on the screen. Don't have people remember it, keep it in their head. If anyone's used not GitHub, but Git, you will have gone through this pain. What is the ability to do, X, Y, or Z? Well, it's a -F, then it's a this, then it's a, I don't want to remember this. I want to see it. I want to find it. I don't want to have to try and keep it all in my head. Our working memory is really limited. Our long-term memory is very limited. So don't rely on them. Put it on the screen. Let people find it again easily. That's what we're doing. We're helping people think through and process information by presenting things the right way. Here we are back to our visual attention. And I said that your attention and your visual search, this thing, decision and response selection, is based on your perception. And that your attention ultimately drives what you perceive. So I don't know if I can show you videos properly with this, but I'm going to try. So bear with me, please. You may not see, I don't think you need to hear any audio at all. So. All right. No need passes to the making. All right. They're not great passes, by the way. I love that bag. Much for it. He's got some good moves. Oh, the moonwalk is not that great. Um, I just love that video. Sorry. Right, the moonwalking bear for change blindness. This is not that abnormal. It were really bad at when you said look at the players in white. Notice they chose the players in white, not the players wearing black, because the players wearing black, you're more likely to have noticed the moonwalking bear because the bear is darker color as well. That's what you're attenuating to. You're attenuating to
the objects dressed in black in white instead of the object dressed in black, and therefore when the black bear comes in, you go, whoa, there's another player on the field. Oh, it's a bear. What the heck? But here's another task. Identify the lumps and nodules in a patient's lungs when you're looking for cancer and an abnormal growth. And they actually gave this to, I do believe it's oncologists looking at cancer growths in lungs. Right. So people are looking for nodules like, down here, for example. I'm assuming those are nodules in the lung. Okay. 83% of radiologists, though, miss the gorilla. The gorilla, right there. And in case you don't think you would ever fall for this, I'd like to ruin a movie for you. Now, it's probably not that big of a deal for you to ruin the movie right now. It wasn't as big as it was back in my day, but I still, when I found this out and someone pointed this out, I'm like, oh my God, you ruined the movie for me. So there we go. Anyone recognize this? This is Star Wars: A New Hope. Anyone notice anything special about the scene? Yeah. Stormtroopers, I mean, everyone knows about this now since the internet, but this was like, it's in the original film. I've seen this film to the point that I have memorized every single line in the film. Yes, I am a nerd. And yet did not see this. I'm looking at this guy up front when he walks into the room and turns over to the side and, breaking the room. They're costing 3PO and R2. They're madmen. Oh my God, I should know the words now. It's been years since I've watched the film, actually. But the fact that there's a stormtrooper that wham hits his head on the bulkhead and falls down and no one notices. Watch it again if you don't believe me. It's like, how did I miss that? Right. It's a famous, and they left it in. They even enhanced it in the newer versions of the film. Right. It's just, wow, no one notices this thing. Right. That a stormtrooper's hitting his head and no one notices for like 20 years. There's a potato in Empire as well as one of the asteroids, and I think they put a shoe in Jedi, but those are intentionally placing those in. This is just an accident. The fact that you don't see it because your attention dictates what you perceive. This is where gists come in. A gist is a 100 millisecond glance, and the weird thing about it is you can swap out images and no one knows. So what we're looking at is, are there things you can present to people that they're going to see automatically and they're not going to misinterpret what you're showing them? So this is what we look at for a gist. So we take something like this scene here. We can actually, for 100 milliseconds, we show them this scene here, and we manipulate the scene to show completely different surroundings and see if people say, this is what I saw last time. So we go from here to here, and people will actually say, yes, this is the image I already saw. Statistically significant. Same with this field that then goes to this parking lot. In this 100 millisecond period of time, people will say they already saw that image. They won't say it for other images, just the ones with the same shape, because that's how we're seeing things. Interestingly enough, though, one of the interesting parts about a gist is that some things are more important than others. And so the really, really light blue is things we don't give two craps about. Dark is about, we notice it somewhat, and red is very attenuated too. Look what we have here. This hill, no one cares about. They don't notice it at all. You can change anything you want in it, no one notices. The river, you see a little bit. This, you see a little bit. The river, you're seeing a lot of. These trees, you're seeing a little bit more of, and there'll be a little bit of the sky. The mountain itself, we don't pay attention to at all. Look what we notice. People, people, people. The thing that stands out that we have no ability to tune out is people. We also pay attention to bathrooms themes. Art studios are pretty good. Bedrooms, we notice right away. Objects ranked according to objective score. So mountains, no one sees. Trees, no one sees. So we all love the wilderness. We all love the woods and stuff like that. Yeah, we don't notice it though. We notice the thing that's going to kill us maybe, or that's important, like people. A person sitting is important. A person is generally important. The floor is sort of not important. And in terms of seeing like a broadleaf forest, barely anyone notices a broadleaf forest versus a bathroom, people notice. Weird things. The point of this, if you know what people will attenuate to, you know what to present to them to make sure that you're guiding their attention. So if I see a gist, I want to see what do I remember from it. So this is what part of the remember that study we had with chart chunk. And this is one of the points of chart chunk, is that we have different qualities of work. So this is work on memorability. How memorable is chart chunk? And one of the things that people find is, so we have eye tracking data, what people looked at, fine. Infrared camera, visual display, eye tracking computer, fine. The most memorable stuff. Turns out things with jaws on them tend to be very, very memorable. What a surprise. Dinosaurs attract attention. We shouldn't be surprised by dinosaurs should be weird. You know, anything that's going to eat you attracts attention. Hinges, joints, contours of things attract attention. Least memorable stuff, bar charts. No one cares. You see so many of the damn things. Look at this. They're spending all their time reading the things up here and glancing at the pie chart. Just barely glancing at it. Look at the bar chart. You saw the biggest number and really nothing else. So even if it's correct in terms of how we look at things, what we look at first and what we pay attention to are different. Much like the stormtrooper hitting his head. We don't pay attention to it, although we should. In terms of conveying data, recognition, we recognize JAWS. What a surprise. We recognize text, we recognize things like this, fine. I think this is the least recognizable, or this is what we recognize. Visual, but we essentially have visual associations that we really want to pay attention to. Things that we're used to seeing, or things that might be dangerous, oftentimes, that really get our attention. We also have semantic associations, things that are just, they're conveying the data, but they don't really have, they're not really, a bar chart does not really, it's of danger. So human recognizable objects would be a visual association, visual annotations, a plot, for example, what, this is this big thing, here's this arrow, right? What we should be looking at are things that are what we visually associate with important data. Titles, textual description, that's a semantic association. So if I'm reading the title, what kind of captions I have, text descriptions, these would be meant like the knowledge is there. And label and axes. In terms of recall, what's interesting is here's what they were studying in terms of recall. What people remembered about these things. The title was number 1, the labels were number 2, paragraphs of text were number 3. The source, no one noticed. I'll notice it from your projects, but at the same time, yeah, people take advantage of the fact that no one notices where the source is. And the axes are not that important. The data itself is not even as important as the title. So good titles help. Don't skimp on the titles, don't skip on the labels, don't skip on the axes. It helps, surprisingly. Election debate is a crappy title. 66% of Americans feel Romney performed better than Obama in the debates. More memorable. And in terms of memorable or forgetful, high quality versus low quality, here's what we have. It's memorable and high quality. It's memorable and low quality. That's pretty crappy, but it's memorable and low quality. You don't convey a lot of information at once. But you see that cotton. Ooh, look at that. Low quality and not memorable is down here. Very memorable, but low quality. This is forgettable and high quality. I'm not even sure if that's high quality myself, but is over here. What we want is to find things that are up in this range, which means good labels, good information, maybe something that entices people to look more, but not skimping on the data itself. There's a fine line. That's where we're looking in terms of effectiveness. We have visual associations, semantic associations, we have message redundancy. So the same message, 66% of Americans feel Romney won the debate. And now there's data that backs that up. We have text, labels, and we also have bar charts. We have things that, and we have colors that match. Here's Romney, almost invariably, here's Obama. It's associated with the color of the party. Easy enough to do. And data and message redundancy helps drive it home. Just in case you miss one thing, we give another signal, if you can do it. In terms of this, human recognizable objects do not, from what they were finding, do not hinder recall. In fact, they actually may help. They help fixate your eye on certain areas. And recall is of a higher quality. So it can help with message redundancy. Here would be a human recognizable object. Instead of saying the word China, Korea, Japan, and India by itself, what if I put flags there? It's redundant information. You just said it was China, but it helps people recognize things faster and keep it in their heads, provided you recognize the flag of the country. But right, this is part of what we're trying to do. It's subtle little things, but they make a big difference. If you want at-a-glance content, titles and text are key. Human recognizable objects or pictograms, if they don't get in the way, are awesome. So an iPad, an iPod, a cookie, a dog, right? You recognize it. Redundancy helps with recall and understanding. And we have empirical evidence of this. So redundant information, human recognizable objects, good text, all are critical for helping you understand things. So this is what P3 is all about, playing around in this area. So you pick the appropriate plot type based off of what you're looking at. I'll be looking at your P3, that's fine. I expect to have things that are, quote unquote, wrong. They're not wrong, but we're just, it's a first pass. So we're trying to find the right plot type. We always want proper title and text just to make sure people understand what's going on. We want redundancy if we can. We want to be able to, we're trying to pack in as much data and information as we can, but without just overwhelming people and getting nothing for it. If you can't see the forest for the trees, it's a problem. So what we want is, we want a clear signal that you can change how things go. That's when we get to interactivity. That's actually where interactivity comes in. Because if you can now select what type of data you're looking at, you get that you can get that redundancy, you can get that clear signal without necessarily getting in the way of what people are trying to like. There's only so much you can show at once. Interactivity gives you that other dimension, the ability to choose what data you're looking at a time. And human recognizable objects can help with recognition. Here's my word of warning. Turn off faces. Turn off faces? Turn off faces. Right. They're problematic at best, but I think they're a good illustrative example of issues that you run into. Turn off face, invented in the 1970s. Check off turn off. Anyways, developed in the 1970s by a mathematician. He found out that people are really good at recognizing faces. So he thought, best thing we can do now is represent data using a human face. Because clearly, if we're really good at recognizing human faces, therefore we should use a human face to encode data. So what you could do is change the eye size based off of one attribute, like the wage. Change the nose length based off of the amount of time they spend in the gym. Change the amount of smile based on their happiness index. Change their head shape based off this. Change this. But you're essentially encoding the data on different attributes of a human face. That's the thought or the concept. My supervisor, doctoral supervisor, was very good at not looking bad by simply saying, so David, what do you think of this? And I'd go off on it. I'd start screaming how horrible something is. This would be one of those examples. Turn-off faces are problematic in many ways, but they illustrate a general problem that we have in a lot of communities. If I put a line of best fit for something that does not have a good correlation, what do you see? You see a line, you see a correlation. Whether it's there or not, you will see it. If you put a scatter plot and you change the scales on things, you lie through the data that way. If you encode data using a turn-off face or a face, what do you see? So this, by the way, is perhaps the only good, it actually won an award, but only good turn-off face. And I know there's a knee-jerk reaction that many of you are going to do. This is from the early 80s, so it's a different time, but in the early 80s, the knee-jerk reaction is when you talk about race, people get, concerned, and rightfully so. But this is the only example of a turn-off face that I've ever seen that actually conveys the information relatively well because it's conveying something very, very particular. So life in Los Angeles, the amount of roundness of the face is the amount of affluence. So presumably as you get more out, your face gets thinner at the bottom, it's showing that you're not eating as much and therefore it's conveying that information. You have unemployment rate is based on how much you're smiling. The urban stress is based on how your eyes are looking, if you're looking angry, if you're looking happy. And then you also have the proportion of the white population going from high to low, which of course is conveying just only whiteness, which is not, just kind of, I don't know how you want to describe stupid, idiotic, or what. I mean, not versus not, white versus not white always seems like a ridiculous demarcation, but fine. It's what they're trying to show here, at least. This is the one example of a turn-off face that I thought conveys a message for one reason. And because you're really good at reading how angry people are based on their eyebrows and their eyes. You're really good at seeing how happy somebody is based on their smile. You're really good at seeing if, roundness of the face shows amount of, fat content in your body, for the person. And so if you're presumably less affluent, or at least traditionally, if you were less affluent, you were skinnier. Not anymore, but that was, for hundreds of years, that would be the case. And the skin color sort of is going along with this, but this is suggesting just the tone of someone's skin, not necessarily the amount of whiteness and the number of white people in a neighborhood. But this would be the only example I can come up with the turn-off face for that was, useful. What's wrong with turn-off faces? I'd love to see what people's opinions on this are. Can anyone see what the particular issue I'm trying to point out is? Other than they're creepy. Yeah, Chekhov's gun, turn-off face. Okay. Colors don't match well, even if you left it all black and white, though. So yes, you're right. Colors don't match well because you're just sort of ignoring large amounts of diversity, the Hispanic population. Oh, it is the, yeah, it's hard to trends quickly. I'm not even sure about that part. There's another more fundamental issue with it. But yes, you're right. You don't see a trend quickly, but I'll go even different kind of life factor, actually. But I think I agree with the life factor part. But how hard it is to see the different shapes. Yeah, you really can't distinguish between, let's say, this and this that well, or this and, let me see here, this and this that well. Distinguishing between those different things are going to be difficult. But yeah, and then yes, but you are actually right, and Carrie, you're also right. You're not going to see the trends very quickly, but why does that look like Los Angeles? Isn't that LA? I don't know LA well enough. The actual Los Angeles is like, this would be a different community outside of Los Angeles, I presume. It's all just sprawls. I found I do not like Los Angeles when I visited it. So let me put it a different way. Can you tell me, you could tell the difference between this guy, this figure, and this figure, right? What's the difference in the data? Inglewood is in the LAX is here. Isn't this Inglewood about here? I don't know my LA very well. Oh, okay, you're looking at the map right now. Okay. For all we know, could be that this is west and this is east, north, south. That's I'm assuming this is south central, would presumably be. If all the gangster rap from way back in my youth, anything to say about it, this would be South Central LA. That's the only thing I can guess. Um, yes, yeah, I don't know why I was listening to gangster rap. My rebellious stage. Okay, so my question is, do you actually see it as a bunch of different component data? It is a glyph. It is conveying a whole bunch of data at once. Do you see it as a glyph? Do you see this as a white neighborhood where that is somewhat urban stressed with medium employment and a low level of affluence right here? Is that what you see here? What do you see? Yeah, yeah, we went through Inglewood at some point. It's not a bad genre, but it's also not like it's um, it's not the world I'm coming from, so it seems very poser-esque, if you want to say it that way. Um, like me listening to country music, I'm not from that, I'm not working anywhere near. I have no common point of reference. Um, it's different than listening to rap in general, but um, yeah, if you keep looking back and forth the legend, you look make sense of it. Why? That's hitting the nail on the head, but you just may not realize why. When you see you're not Google Photos. When you see a human face, do you see a whole bunch of different parts? You look at your friend and say, "Oh, your cheekbones are 20% larger, therefore you must be my friend Tommy," versus some other person. Is that that's actually what you're doing technically? How you recognize a human face is a series of different parts of their face. But is that the reason why do you consciously recognize that person's face based on those things? This is what you can best describe as an emergent visual processing. You see human faces. The reason you're so good at seeing human faces is that you're predisposed to see human faces, whether they're human faces or not. So when they see this, I do not see a whole bunch of data. I see a human face as a human face. I will recognize the difference between this and this, but I will not recognize this as a whole bunch of different data points. I don't see it as data. I see it as a human face, and therefore I cannot, much like if I combine red and blue together, I see purple. I do not see red mixed with blue. That's effectively it becomes one unit, and I cannot tease out individual parts without going to the legend, looking, comparing these individual parts of the face. We are good at recognizing human faces because we see patterns when we don't want to even see the patterns. That's what I'm pointing out. If you do the wrong representation, you will throw off the visual processing system and you will get the wrong result of it. So turn off face is only really good for this one example because vast majority of times, if you're showing car engine, heat dissipation using a turn off face, it is effectively useless because you will see a face, you will not see eyebrows and a nose and a mouth. Just like I don't see when I see you guys, whenever I see you guys, rather than cats and flowers and cat lying on its back. Right? I don't see, when I see your faces, I don't see a component bunch of parts. I see a face. And if you don't know how the human visual processing works, you're going to make a visualization that's incorrect. If you make why pie charts are ineffective, knowing how we perceive things dictates how things are used. I don't think we have time for an in-class exercise. I want to do this in-class exercise at some point in time, but I also want to make sure we get a little bit ahead of things here. So I'll just preamble to the next thing. But what we would end up doing soon, maybe next week, is looking at making little Valentine's Day infographics and designing those up to see, looking at data redundancy, message redundancy, titles and annotations, and just trying to make a visualization, a data graphic for Valentine's Day. All right, but I want to get to what the actual, I have 5 minutes, so let's see if I can do this. I would like to point out soon I'll be looking, turning, you'll see it in a second. Yeah, I'm watching some Critical Role stuff in case you're wondering. So here, I shouldn't have put my YouTube up there. So in the near future, I want to be looking at storytelling and maps. Why? Because I have a sneaky feeling, I have to look at your P3s, but I have a sneaky feeling that this will be the vast majority. This normally at the end of term when I cover this. And I'm thinking, yeah, and I think most groups are going to be having storytelling and or maps. Okay, maybe I should be focusing on that. So we'll hit that prematurely. I'm going to revamp things a little bit. What we're going to be doing next time around, and I'm just going to preamble it 5 minutes, is that we're going to be looking at interaction, views, and faceting. The idea is when we're looking at things, we do not have, let's try and move this around. When we're looking at things, we already talked about visual perception. We talked about how your attention dictates what you're seeing. Therefore, you can't show everything at once. What if you can let the user choose what they want to see? Or if you were automatically transitioning things, you've got to be acutely aware of where their eye is going and how perception is working. Because what we want is the ability to change from one format to another, to transition from one visualization to another. That's actually where the power of this entire field comes from. It's filtering, it's faceting, it's changing the view of the data interactively. That interactivity gives us the power. So we're not just talking about infographics and the like. We're talking about controlling how things change over time, and that tells us something really interesting. So let me see if I have an example of interactivity. Navigation change. Here'd be an example. I think we've already looked at this a little bit, and I'll stop at this. This would be an example of change over time. The Gapminder visualization by Hans Rosling. So have a look at it if you haven't already looked at it. I can even just walk it. Still working. Here we go. So what we can do is we can select an individual country. We can go to it. Here's our individual countries. We can search by, I think, like all in this group. So we can choose all of Africa. We can choose all of the Americas because that's not one continent. It's not two continents. One. You tell he's European. Select all in that group. Oh no, he has Europe and Asia together. So, or no, just Europe, and Russia is part of Europe. But more importantly, you can press, my mouse being getting covered up. We can press play and we can track how objects change over time. We can have European countries being selected. And notice we have faded out information. We're calling attention to the more saturated stuff using a brighter color, more saturated color. But notice that the shapes are actually moving around over time. This is how cost of living and income versus life expectancy outcomes are changing over time, over a long period of time. You can actually track and follow. This is where interactivity comes in. I can select what data site, what type of data I'm looking at. I can, and therefore, attract my attention to one particular area. More importantly, I can also, or as importantly, I can also see changes over time. The interactivity tells me something that I cannot get. If you just showed me a whole bunch of static images, I would not get that. That's what interactivity is all about. That's what we're going to be dealing with next time, is changing how the data looks over time. That's one of the things I really want to be pushing for your final projects. We're not talking just bar charts. talking about changing this over time. So when I select one type of data, it reflects in the other type of data, or if something changes over time. That interactivity gives me something that I don't get otherwise. Okay, I'm going to be doing office hours now. I'm also going to be turning off the group work if I can in CLearn as soon as I can. But I'm also I'm going to be doing office hours now. I'm going to stop the Zoom meeting, but then I'll restart it up again for maybe for office hours. I know one group at least wants to talk to me. I'll just restart the Zoom meeting, but turn off the recording, and we'll go from there. But I'm going to grab a quick snack. It's 9:55 right now, and I'll be back online very, very shortly. All right. Thanks, everyone.